So this is a relatively complicated question. We have this skeet that was being launched. I will call this big M. So we have this big M that is being launched at 28 degree. Is then when it reaches its highest point, a bullet hit it from below. I call this small m. So afterwards, it acquires an extra velocity in the vertical direction, and because of that extra velocity, its trajectory changes and it travels an extra distance in both the x and the y direction. So we want to know how much higher it gets because of this collision and how much extra distance it travels in the horizontal direction. So this question, it requires the knowledge from chapter 3 about the trajectory motion. And I will not walk through the trajectory motion step by step because that is not the point of this question. It should be knowledge that you already have. But if you have any confusions, try to go back to chapter 2 and chapter 3. So in chapter 2, the main equation you need to know is that Vt squared minus V naught squared is 2ax. This is the equation from chapter 2 you need to know. So I think that's 211. So this pretty much tells you if you have the final speed as the initial speed and you have the acceleration, you can know the distance traveled. So there is this equation you need to know. And another equation you need to know is from chapter 3. So from chapter 3, there is this equation regarding the horizontal range of a trajectory motion. That is x equals naught square sine 2 c naught square over g. So this is an equation that it gives you the horizontal distance traveled by any object undergo trajectory motion if their initial speed is v naught and if their angle with respect to horizontal line is theta naught. So this can also be derived if you do a little bit, if you just walk through if you first find out how much time it will be traveling, because you take the x direct, the velocity in the x direction, and then the acceleration in the x direction, so you can find the time it travels, it stays in the air, and from that times it travels, you multiply the time travels and the velocity in the horizontal direction, and that gives you the horizontal distance traveled. But here I'm just gonna use these two equations. I'm not gonna derive them, and again, you can always go back to chapter 3. So, okay, let's look at this trajectory motion. Let's try to use this equation to find the horizontal distance traveled. So we have x equals v naught squared sine 2 theta naught over g equals, we have 25 meters per second times sine of 56 degree over 9.8 meters per second squared. This gives us 52.88 meter. So that is this distance. Now we also want to find the height that it was about to reach, and that we use this equation instead. So we know the initial speed is the vertical component of v naught, and the final speed is 0 because it does not have any vertical speed at the highest point. So from that, we can find h, this is actually better called h, equals vt squared minus v naught squared over 2g. Negative 2g, because it's a is in the negative a is in the negative direction and the magnitude is negative g, so it's negative 2g. So the final velocity is just 0. The initial velocity is negative v naught squared sine square 28 degree. So the negative sign will cancel each other. Now we can plug in the numbers, and it gives us 25 meters per second square, and sine square 28 degree over 2 times 9.8 meters per second square. So that is 7.028 meter. So this gives us the x and h. So it's all parameters of the original motion without the collision. So I will try to get some extra space by making it smaller so I have space to do the rest of the calculation. Okay, so now let's look at this collision. What happens in this collision is that the bullet gives the skeet an extra velocity, and we can do that by this. Yeah, we can do that by doing the conservation of momentum in the x and y direction. So in the x direction, there is no extra speed, but that does not mean the velocity in the x direction does not change because the mass we have, because the bullet is embedded in the skeet. So originally we only have a mass of big M, and now we have a mass of big M plus small m. And because of that, the velocity in the x direction will change. It will slow down in the x direction due to the conservation of momentum in the x direction. So in the x direction, we have px equals mvx. So this is the original momentum, and afterwards is big M plus small m vx prime. In other words, vx prime equals big M times vx over big M plus small m. And so Vx is, so big M is 0.25 kilogram. Vx is 25 meters per second times cosine 28 degree. And big M plus small m is 0.25 kilogram plus 0.015 kilogram. This whole thing is equal to 20.82 meters per second. Now we look at the y direction. The y direction is the other way around. The skeet itself doesn't have any y component, but the pellet do have a y direction component. So py equals small m times vy equals big M plus small m times vy prime. So this gives us vy prime equals small m vy over big M plus small m. And again, we're putting all the numbers. Small m equals 0.015 kilogram times its speed is 230 meters per second, and divided by the total mass of both objects. This gives us 13.02 meters per second. Okay, so this is the speed in the x and y direction of the skeet after it is hit. So with these two information, we will be able to find both the x direction and the y direction, the distance traveled. So part A is the easy part. It asks us how much higher it will travel. So you can treat that from here, it's like you can treat this part as a trajectory motion of its own, and it moves up with vy prime, and then it goes under the it is under the effect of the gravitational acceleration, and then it moves to this maximum height of h prime. So because of that, you can do it again using this formula. So you can find h prime equals vt squared minus v naught squared over 2a which is equal to negative, so square in the y direction, it's just negative v prime square minus negative 2g divided by negative 2g. And so negative sign cancels, so it's v prime square over 2g. So Vy prime, we know it's 13.2 meters per second squared over 2 times 9.8 meters per second squared equals 8.6 meter. So this is h prime. Now we look at part B. Part B is a little bit more complicated because it depends on how familiar you are with trajectory motion. But now we have, because in the horizontal distance, it is going under the acceleration. So it has an initial distance, and we're looking for this whole motion. So we do have an initial distance, and we have an initial velocity, and we have an acceleration. So we actually have to solve the quadratic equation, because we know, again, this is from chapter 2, and from chapter 2 we know y equals y naught plus v initial t plus 1/2 at squared. And or in this case, the at squared we have, it's actually negative a equals negative g, so it's 1/2 negative gt squared. So right now we have the y, because y is just, it's negative this height, y is negative h. Why not? Or let's say y is 0, and then because this is the final y is 0, y naught is h, and v naught is initial vy prime. We find out here, and then we have g. So from this we should be able to find t, the time. And once we find the time, we will be able to find the x distance traveled, because the x distance traveled is just time. This distance traveled is just time times vx prime. So let's first do the quadratic equation. We can plug in the numbers. If we plug in all the numbers, y is 0, y naught equals h, which is 7.028 meters, plus 13.02 times t, because v naught is vy prime, and then minus 1/2 of 9.8, so that's 4.9 times t squared. I am ignoring I'm ignoring all the units here, because I am just doing the arithmetic manipulation of this equation in order to find the value of t. And of course, in order for me to ignore all the units, I do make sure that all of them are in SI units, which they are. So with this equation, this is a quadratic equation, we find that t equals 10.02 plus or minus 13.02 squared. So that's just the standard formula for the solution of a quadratic equation. .80. So that is either 3.117 second or negative 0.460 second. And of course, it cannot be negative. So it is 3.117 second is how much it travels. Let me try to find some space for the rest of the calculation. It is long, to be sure. So I hope it's still readable after I made everything smaller. Great, so there should be enough space. So great, awesome. This is a time that is traveled by the skeet after. So this motion will take 3 seconds. So we will be able to find how much distance it is by just multiplying. So what should I call it? Let me call it x after. So x after equals vx prime times t. And in the meantime, try to clean this up a little bit by getting rid of some of my drawings. Okay, so now we're putting the numbers because we know the x prime is 20.82 meters per second times the t we have is 3.117 second. So that gives us a total of 64.90 meter. Okay, we're almost done. We're very close. The last step is to find what is delta x. And we know that because we already know what x is. We already know this distance. So then this much is just half of this distance, but at the same time, we know x after. So we just subtract f after by half of x. So delta x equals x after minus half of x. That is 64.90 meters minus half of oh, was it that small? Was it just 7 point? Oh, sorry, minus half of 52.88 meter. Okay, that makes so much more sense. And this gives us 38.46 meter, around 38 meter. Whew. So finally we're done. This is delta x. Yeah, so if we finally try to think through this very long question, what we did was that we first find out the original parameter, we find the original horizontal distance and height that will be achieved, and then we add in the collision and we find the new speed after the collision in the x and y direction. And then we use also kinematic equations to find the extra height that will be reached, which is the easy part. But then we also use the quadratic equation to find the horizontal distance that will be reached. And from that horizontal distance traveled, we find the extra distance delta x. So the final answer we get is that it gets this skeet get 8.6 meter higher and it travels 38 meters further because of this collision.